Hi friends, welcome to another wonderful day of distance learning. We are going to be looking at how to factor special cases today. So let me share my screen with you. I hope you're all well. I hope everything is going well for you. There it is. Okay, so go back into the Meet and present a window. We're going to take that window and we're going to do that one. Okay, great. Here we are. So we're going to actually hit the most important points from chapter 8, sections 7 and 8. We're not going to actually go through the entire stuff, all the things from those sections. We're just going to condense it and make it as quick as we can. So here's your anti-set. As promised, they are our diamond problems. So this is a really great time to go ahead and pause the video and try these on your own. All right, friends, and welcome back. So for this first one, something times 7 makes 91. So we do 91 divided by 7, and we get 13. Oh, you gotta make it so it lets me write. Okay, so we get 13. And then 13 plus 7 is 20. Here, we're doing something plus 9 makes 29, so that is 20, and 20 times 9 is 180. Here, we're doing 16 plus something makes 24, so that's going to be 8. 8 times 16 is 120. No, that's 128. Sorry about that. Okay. 16 times 3 is 48. 16 plus 3 is 19. Then on this next one's 238. 238 comes from 17 times something. I'm doing the math over here on my whiteboard. And that's going to be a 14. And 14 times plus 7 is 31. And here 16 plus something makes 28. That is 12. And then 16 times 12 is 192. Okay, so that is the information for our diamond problems for today. Taking a look, objective. How do you undo multiplication? We know that factoring is how we undo multiplication. And in this case, we're looking at how do we undo multiplying polynomials, which is a little bit trickier than just something like 3 times 5. So today you're going to be able to look at special cases of polynomials. Mathematicians are super lazy and we love shortcuts. So some of these special cases for factoring have some shortcuts, which are really great. Today, we just have one of those practice sets for you in Google Classroom. We know it's been pretty heavy on the digital stuff lately, so you can always print out this practice set, or you could have the practice set up on a screen, but then do the work on paper. If you want to do it online too, that's fine, and use your equation editors to type in there. But this one is just going to be pretty basic practice for you. Okay, so factoring perfect square trinomials. This might come in handy later when it comes to your closure question. So what I'd like for you to do is think about either taking notes or remembering what I say next. So here we know that this is a perfect square trinomial because we have a perfect square as our last term and we have a perfect square as our first term. So we could factor this like we normally factor. Let's see if I can go. Okay, so we can make our grid. and our x squared goes here, and our 9 goes here, and then we do x squared times 9 is 9x squared, and our 6x goes here, and we think about what multiplies to 9 and adds to 6. Then we get 3x and 3x. And then we factor out, and we get x plus 3 and x plus 3. And so x plus 3 times x plus 3 is our factored form, and we can write that as x plus 3 squared. But what we can recognize is that if we have a perfect square here and a perfect square here, then we can just write it as that x plus 3 squared, which is a shortcut. Obviously, both ways work. If you want to factor it like normal, you can factor it like normal. If you don't want to factor it like normal, you can use the shortcut. Here's another perfect square trinomial. We know it's a perfect square trinomial because we have a perfect square here and we have a perfect square here. Okay, this one's a little different though because we have a subtraction sign here where we had a addition sign in this last one. Right here we had an addition sign. So we just need to take into account something here. We're going to, if we do our diamond problem and our box, we have our x squared, and we have a 9 here, and then we can put our 9x squared here, and this becomes a negative 6x, which means that both of these factors are negative 3, so we get an x minus 3 and an x minus 3, so our solution is x minus 3 squared. So here the shortcut is if we have a perfect square in our first term and a perfect square in our second term, and all of our terms are adding, then we can do an x plus some number here and square it. Sometimes the number out in front of the x here might not be a 1, in which case we can take whatever the square root of this term is and put it here. And we can take whatever the square root of this term is and put it here. And that's a nice little trick. If we have a minus here, we just put a minus right here. Nice little trick, okay? Something else with perfect squares is if we have a difference of squares. We have a difference of squares if we only have 2 terms, like we only have 2 terms here. Difference means subtraction, and squares means both terms are perfect squares. When I say perfect squares, anything times itself, like x times x is a perfect square, and 81 comes from 9 times 9. So let's just take a look at what we would do with our traditional method if we wanted to use it, okay? We would have a negative 81x squared up here, and we would have a 0x because there's no bx term. So just put in a 0. So then we're asking what adds to 80, adds to 0 and multiplies to negative 81, and that's negative 9x and positive 9x. And that means that we can factor out our GCF, and we get a minus 9 and we get a plus 9. And so if you recognize if something is a difference of squares, where you're doing 2 terms that are subtracted, and we have perfect squares for both of those terms, then you can take the square root of your first term and do plus the square root of your C term, and multiply that by the square root of your first term and subtract the square root of your second term. So x plus 9 and x minus 9 is our shortcut. Well, then the last thing, or here's another one. So this one, it's a perfect square here and a perfect square here. The thing is we don't have a 1 in front. So the square root of 9x squared is 3x. And the square root of 16 is 4. So using our trick, we can do 3x plus 4 and 3x minus 4. We don't even have to use the box or the diamond problem, just real quick. Okay, so then here's the last question, last special case for us today is what if we don't have 4 terms? Well, or what if we don't have 3 terms? What if we have 4 terms instead? That's okay. We're just going to put 1 term in each part of the box, And then we're just going to factor out our GCF. So looking at this first row, what's our GCF of this first row here? And we see that 6x cubed and negative 4x squared have a 2x squared in common. So then we ask what multiplies by 2x squared to make 6x cubed, and that would be 3x. Then we can ask what multiplies by 3x to make 12x, and that would be 4. And then we have our 2x, and we need to figure out what multiplies by that to make negative 4x squared, and that is negative 2, and 4 times negative 2 is negative 8. So then we can write our factors, 2x squared plus 4 and 3x minus 2. I see that there's a common factor here, and so it's not fully factored yet. You always need to check and look and see if any of your factors can be factored down further if you have 4 terms. And in this case, I can pull out a greatest common factor of 2, and I get x squared plus 2. And so this would be my fully factored answer. Okay. So your practice. You have the practice set in Google Classroom. This practice set should take you no more than 45 minutes. If it's taking you more than 45 minutes, please stop. You can come back to it at a later time, but definitely let Miss Olson or I know that it's not working out, and then we can help you so that you can maximize the time that you spend on it. You can be as effective as possible and not struggle. We do not want anyone to struggle. If you are struggling, please reach out to us. We want nothing more than to help you and help you feel good about the work that you're doing. Okay, checking in on our objective. How do we undo multiplication? Can we factor special polynomials? Those special polynomials are perfect square trinomials, difference of squares, and when we don't have trinomials at all. So in your notes, I'd like for you to write, how can you tell if something is a perfect square trinomial or a difference of squares? And remember, the key here is that both of these have squares in them. Well, that's it for today, friends. Hopefully you can get working on that practice set. We do need you to upload that practice set to Google Classroom for a grade. We would like that by the end of the block cycle. Thank you so much and have an excellent, excellent day.